Hello, good morning. I'm Sonali here. We are in Education on Cloud. For class 10 science, we have a chapter name Magnetic Effect on Electric Current. Let's see the important points. We will revise it quickly. Okay. Now, what is magnetic field? Magnetic field here, the space surrounding a magnet which is an influence in the form of magnetic force. Okay. So, we can see here. So the magnetic field is the space surrounding a magnet in which its influence in the form of magnetic force can be detected. That is only called magnetic field. Okay. Now magnetic field lines. How magnetic field lines will be? The curved imaginary lines to show the magnetic field in a given region. Okay. So magnetic fields are closed continuous curves directed from north pole to south pole. Okay. You should remember north pole to south pole outside the magnet, but from south pole to north pole inside the magnet. It will be like this. Okay. The tangent at any point, like we can see here, north pole to south pole outside the magnet and south pole to north pole inside the magnet. Okay. So like this, these are called field lines around a bar magnet. Okay. So now at any point, tangent at any point on the magnetic field gives the direction of magnetic field at that point. So magnetic fields are closer together at the poles and far apart at the center. We can see here closer together at the poles and far apart at the center. So never intersect each other. The magnetic field cannot have two directions at a point. They never intersect and they never have two directions at a point. Okay. Now when an electric current is passed through the conductor, then the magnetic field is produced around the conductor. So the conductor behaves like a magnet. In that case, conductor will start behaving like a magnet as long as the current flow it. What is happening? When an electric current is passed through the conductor, the magnetic field is produced. Okay. And around the conductor. So that conductor will start behaving like a magnet as long as the current is flowing there. Now Ampere swimming rule, if we discuss, then imagine a swimmer swimming in the direction of flow of current and always looking towards the needle such that the current enters from his feet and leaves from his head. So the direction in which the left hand of the swimmer point gives the direction of motion of the north pole of the magnetic needle. Okay. Now Snow rule will be, according to this rule, it states that if a current is flowing of an electric circuit from south to north direction and a magnetic compass is placed over a conducting wire, the needle of the compass deflects in the direction of the west. Okay. Now right hand thumb rule, if we are talking, see here, this is the right hand thumb rule. So the thumb will be indicating here, we can see thumb will be indicating the current and the fingers which are being closed, that is indicating magnetic field. Okay. So this is called right hand thumb rule. Right hand thumb rule, according to this rule, imagine you are holding a conductor with the palm of your right hand and such that the fingers encircle the conductor and the thumb point in the direction of the current. Okay. So then the direction of the fingers encircling the conductor gives the direction of magnetic lines. So if you are encircling like this, so your fingers are giving direction of magnetic field and the thumb is giving direction of the current. Okay. What do you mean by solenoid? Solenoid is an insulated copper wire around some cylindrical cardboard or plastic tube such that its length is greater than the diameter. So it behaves like a magnet. Okay. It behaves like a magnet and when a current is made to flow through it, that is only called a solenoid. Okay. Now electromagnet. What do you mean by electromagnet? A solenoid which has an iron core with its electromagnet. So the iron core intensifies the magnetic field of solenoid and iron gets magnetized due to magnetic induction. So now what is Fleming's left hand rule? Fleming's left hand rule is stretched here. See here, this is the left hand rule. So this is the left hand. Here the pointer finger is indicating a magnetic field. Here the middle finger is indicating the current and the thumb is indicating force or motion. Like this we can see here, the current, force or motion or magnetic field can be indicated. So stretch the thumb, forefinger and middle finger of your left hand mutually at right angles to each other such that forefinger points of the direction of the magnetic field and forefinger will point the direction of magnetic field, middle finger will point the direction of flow of current, and the thumb gives the direction of motion of the conductor. We can see here motion of the motion of the conductor, magnetic field and current. It is given by left hand. Okay, the pointer finger, main finger, and forefinger, which we can call middle finger, and the thumb. Then what do you mean by electric motor? Electric motor is a device which converts electrical energy to mechanical energy. That kind of device is called electric motor. Okay, now what is commutator? Commutator is a rotating device which changes the direction of current after every half rotation. That is only called commutator. Okay, now Fleming's right hand rule. This is the right hand rule. We can see here. So thumb is indicating movement of conduction. Then you can see pointer finger is indicating magnetic field. Okay, and the another finger, the middle finger, will indicate current induced in conductor. Okay, so we can say here motion, field and induced current will be in this direction. So Fleming's right hand rule, if we discuss, stretch the palm of your right hand in such a way that thumb, forefinger and middle finger are mutually at right angles to each other. Now point the thumb in the direction of motion of the conductor and forefinger in the direction of magnetic field. So direction of middle finger gives the direction of induced current here. Okay, what do you mean by electromagnetic induction? Here the phenomena due to which changing magnetic field with a conductor by a closed coil induces electric current in conductor or coil is called electromagnetic induction. Now what is induced current? Induced current is alternating current. This is an alternating current produced in a conductor or a closed coil. When the magnetic line of force rapidly changes in it, it is only called induced current. It is always alternating in nature. Okay, now Lenz's law we will see. According to this law, all the cases of electromagnetic induction, the direction of induced current is such that it always opposes the cause, the motion of the conductor which produces it. Okay, now mutual induction, if we discuss, that is the phenomena of production of induced induction in a closed coil by varying magnetic flux in another coil. That is only called mutual induction. Okay, then what is AC? Alternating current. Okay, an electric current in which direction of current changes after equal intervals of time. That is only called alternate current or AC. The electric current supplied for the domestic or industrial uses is only alternating current. Okay, now what is electric generator? Electric generator based on phenomena of electromagnetic induction. It converts mechanical energy to electrical energy. Okay, converts mechanical energy to electrical energy. Household wiring is done in parallel, so it provides with safety devices such as fuse and earthing. Okay, so there always it is done in parallel. Now electricity for domestic purpose is supplied at 220 watts and volts and 50 hertz. Commercial electricity will be 440 volts and 50 hertz. So this value is fixed for domestic purpose, 220 volts and 50 hertz, and commercially 440 volts and 50 hertz. Thank you.